Alright, hello students. So if you're watching this video, it means that you've checked Schoology and you read my update and you've clicked on this link right here. So again, if you're on this video right now, you're watching, it means that you've gone on Schoology and you read my post. It said, "Good morning students, I have a new lesson video for you to watch. Today you will need to do the following. Number 1, watch the entire Wednesday's lesson video. That's the video you're watching right now. And number 2, turn in homework vocabulary practice on Schoology." Now, there's a big hint that I gave you. It says you can only see today's assignment once you have watched the entire video. So the reason why I'm doing this is because I want to make sure that all of you are watching all of the video, not just the beginning part of it or not just the middle part, but I need to make sure you've watched the entire video because it has very important things that I'm going to go over today, and that'll help you on your quiz on Friday. So to make sure you've watched the entire video, I'm giving you this hint that you can only see today's homework assignment once you've proved to me that you've watched the whole video. Alright, so again, you're watching the Wednesday's lesson video, and now I'm going to open up the online learning week 2 slides. So you're going to click on this and it's going to open up to our slides. Now you've already seen this letter, you've already seen Monday's work. So hopefully on Monday you've turned in this homework assignment. And then Tuesday, which was yesterday, you watched the video with the directions and you completed all of your missing assignments. And I saw many of you practiced J.2 skill on IXL. So that was Tuesday's work. And now it's Wednesday, March 25th. So I'm going to press present. And we're going to go through the slides together. Alright, so for our do now, the topic is thermal energy. Our learning objective says, I will learn about how thermal energy transfer changes the kinetic energy of particles, which results in a change in temperature. And how will you learn this? By watching demonstrations that I filmed for you. So for our class agenda, we're going to review the balloon demonstration, and then you'll watch a video of me showing you how to use a thermometer. And then number 3, you'll watch another video of me showing you how we will collect evidence of thermal energy transfer. Now for your homework again, you're going to go on Schoology at the end of this video and you're going to complete this assignment by Thursday night. You will not be able to see this assignment until you've reached the end of this video. All right, going next. See what happens. One more time to remind you all, the balloon has air particles floating around. Now let's see what happens when I place this balloon over the fire. Oh, let me drop. Here we go. Ready? Alright, so I just replayed the balloon demonstration that you saw on Monday. So our guiding question was, why did the balloon pop when placed above fire? And on Monday, your job was to complete this homework assignment, which was the response to the guiding question. So those of you who did it, thank you very much. I'm going to go over it with you right now. So for this homework assignment, you were supposed to place these sentences in the correct order to explain why the balloon popped when placed above the fire. And I know it was a little bit tricky. I know some of us didn't get a score that they were proud of, but if you watch this video, I'm going to explain it all to you. And then on Friday, you'll get another chance and you can improve your score. All right, so again, I'm going to go over the answer to this question. So why did the balloon pop when placed above fire? Well, first, there are air particles in the balloon. So imagine that this green box is the balloon. There's air particles in the balloon that are moving around with low kinetic energy. So one more time, imagine this is the balloon, and inside there are air particles that are moving around, and they have low kinetic energy. They're not moving that fast. They're moving just a little bit. Now, the fire, the candle, has thermal energy and it is a source of heat. So thermal energy transfers from the fire to the air particles inside of our balloon. So again, thermal energy is added to the particles inside of our balloon. Because remember, thermal energy always moves from hot to cooler objects. Now, the particles, as they gain more thermal energy, This increases the kinetic energy of the particles, making the particles move around faster. So as the thermal energy is going into the particles start to move around faster. They have more kinetic energy. This makes the temperature of the air inside the balloon increase as well. Remember, increase means to go up. Now the last answer, the particles move faster with more kinetic energy. So imagine how quickly these particles are moving. Now that they have so much thermal energy, they're moving so fast. And as they move faster and faster, they want to spread out. They want to move away from each other, and they are spreading out and going like crazy inside the balloon. And as they move around faster, the particles are going to keep hitting the walls of our balloon. So the particles keep hitting the walls of the balloon, this green wall of the balloon. And when this happens, they move around with so much force and energy that it makes the balloon pop, because the particles want to escape. They want to spread out. So because they keep bumping into the walls of the balloon, it makes the balloon pop since it can't stretch anymore. So that was the answer to our question. So again, if you want to fix your answers, I'll open up another attempt on Friday. You can go and change your answers if you need to. All right, moving forward. Now I'm going to teach you how to use a thermometer to measure temperature. So this is a thermometer. A thermometer is a tool used to measure the temperature. And remember, temperature is the average kinetic energy of the particles. So it tells us how fast or how slowly the particles are moving. So in this case, if these particles are not moving that fast, they're moving slowly, then the temperature is going to be low. It's not going to be a high number. Like imagine driving a car. If your parent or guardian is driving slowly, then their speed is going to be small. It's going to be a small number. However, if the particles are moving very fast, then remember, temperature measures the kinetic energy, how fast they're moving. So if they're moving fast, then the temperature will be very high. Just like if you go very fast in your car, the speed is going to shoot up to maybe 60, 70 miles per hour. So kinetic energy is measured by a thermometer. Thermometer is what is used to measure the temperature. All right, so in the thermometer, it's filled with this red liquid called mercury. So mercury is in this liquid form, and it's inside of our thermometer. So the mercury is all over here in this liquid form, and it travels up or down the thermometer. So when the thermometer touches something very hot, so when this part of the thermometer touches something very hot, the mercury particles are going to gain thermal energy. The mercury particles in the red liquid are going to start to move faster. And just like in the balloon, when the particles move faster, the red liquid will start to move up the thermometer. It's going to start to move up because the particles are spreading out and taking up more space, like the balloon particles, the air particles in the balloon. As they move faster, they start to take up more space. So the red liquid is going to go up the thermometer because it's spreading out. All right, so in this video, I'm going to show you how to use a thermometer. So this is a thermometer. It's a tool that we can use to measure the temperature of different objects or different spaces. So here is the tip of the thermometer, this right over here. This is the part that you place on whatever you're trying to measure the temperature of. And the red is called mercury. Mercury is inside of our thermometer. And what happens is, remember, temperature measures the average kinetic energy of the particles. It measures how quickly or slowly the particles are moving around. So what happens is if the thermometer touches something very, very hot, then the thermal energy from the hot object is going to come and move, transfer to the mercury, and these mercury particles are going to start to move faster and faster, and they're going to need more space. So then the mercury over here is going to start to move up, 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 because the particles in the mercury are moving faster since there's more thermal energy, and that's why the number of the temperature is going to increase. So for example, right now, here in this jar, I have hot water. So if I put this inside the hot water, I'll show you what happens to the mercury. So as you can see, the red mercury is going up, it's increasing because the temperature of the hot water is being measured. And remember, hot water has particles that are moving around very fast. So as thermal energy from the hot water is transferring to the mercury in this thermometer, it makes the particles in the mercury move around faster, and they start to expand and take up more space. So that's why that red mercury moved up. So here's how you can measure the temperature. So the temperature of this hot water right now is slightly above 100. So it's around 100 and, let's see, 100 and around 106. That's the temperature of this hot water. Alright, so one more time. When the thermometer touches something very hot, the mercury particles will start to gain thermal energy and move faster. As they move faster, the red liquid would start to move up because the particles are spreading out and taking up more space. So now if I take my thermometer off and I put it on this ice cube, what do you think will happen? Well, remember, the particles in the mercury of our thermometer, they're going to start to lose thermal energy to the ice because the ice is colder. So as the mercury particles in the thermometer start to lose thermal energy to the ice cube, they're going to move around less and less and less. So then they're going to take up less space. So then the red mark should start to go back down because they're taking up less space. So let's see if that's what happens. So I'm going to place the tip on our ice cube. And here's the red line. Let's watch what happens. So you see the red line is dropping because the particles in the mercury, the red, is moving less and less as they lose thermal energy to the ice cube. So it's losing energy to the ice cube. And it's moving less and less. That's why it's taking up less space. And the red line is going to keep dropping. So it's still starting to drop more. It's slowing down a little bit. The particles in the mercury, the red line, they're losing thermal energy. So they have less kinetic energy. So the mercury is taking up less space inside of our thermometer. All right, it looks like it's about to stop moving. So right now, the temperature we're gonna say is around 50 degrees. So when it stops right there, that's gonna be around 50 degrees. And why is that the case? Well, you know that in ice, the water particles in ice, they're not moving around that much. They're only vibrating side to side because they have less kinetic energy. And remember, thermometers, the temperature measures the kinetic energy of the particles. So if the particles are moving around less, then the temperature should be a lot less. So it is still dropping, so temperature is a lot less because the particles in the ice cube are moving around with less kinetic energy as opposed to the hot water. Okay, so in this demonstration, we're going to talk about how we might know that thermal energy has transferred. So here I have, again, a beaker of hot water and an ice cube. So right now I'm going to show you the temperature of this ice cube. We learned how to use a thermometer. So this thermometer tells us that the ice cube is between 40 and 60. So we're going to say it's around 42, 44, 46 degrees Fahrenheit. So the temperature of this ice cube, again, is around 46 degrees Fahrenheit. All right, so in this demonstration, we're going to collect evidence of thermal energy transfer. So you saw that the water particles in the solid state, which is ice, are moving around very little. So the particles have low kinetic energy. And remember, temperature measures the kinetic energy of the particles. So since the particles have low kinetic energy, the temperature of the ice is also very low. And if you forgot what a solid looks like, here's an example of a solid. The particles, they're vibrating side to side. They're not just staying still. They still have thermal energy, but they're just moving side to side very little with low kinetic energy. So the temperature was 46 degrees Fahrenheit for the ice. And now we're gonna look at the temperature of this hot water. So the thermometer tells us that the temperature of the hot water, let's see, it's a little over 100 degrees Fahrenheit. So it is 106 degrees Fahrenheit. So this is the temperature of our hot water, 106 degrees Fahrenheit. And the ice cube was 46 degrees. So for the hot water, let me pause it. Now we're gonna, for the hot water, the water particles in the hot liquid state are moving around more. So the particles have more kinetic energy. So remember, since temperature measures the kinetic energy of the particles, since the particles have more kinetic energy, the temperature of the hot liquid is very high. So remember, liquids have particles that are moving around each other more quickly with more kinetic energy. So the hot liquid was 106 degrees Fahrenheit. All right, so right now what I'm going to do is I'm going to put some of the hot water on top of the ice cube, and we're going to see what happens. So you might already guess. Remember, thermal energy always moves. It always transfers from hotter to colder objects. So I'm going to pour some of the hot water on the ice cube, which means thermal energy from the hot water should transfer and move to our ice cube. Alright, so watch what happens. As I pour the hot water, the ice cube is already melting and getting smaller and smaller. So now we're going to see, how do we know that thermal energy has transferred? What is our proof that thermal energy has transferred from the hot water to the ice cube? Using this thermometer, we're going to measure the temperature of this new mixture of the ice and the hot water. So remember, the ice cube was at first at 46 degrees, but now the temperature of the ice cube is starting to rise up, and it's stopped at around 62 degrees. So the final temperature of this mixture of ice and hot water is 62 degrees. All right, so how do we know that thermal energy has transferred? Well, thermal energy transferred from the hot water to the ice cube, because remember, it always goes from hotter to colder objects. Now, we know that thermal energy has transferred because the temperature of the water changed. The ice was at first 46 degrees, but it changed to 62 degrees Fahrenheit. That's how we know that thermal energy has transferred. When thermal energy was transferred to the water particles in the ice, the particles started to move faster. So the particles gained thermal energy and their kinetic energy increased. So here, the particles gained thermal energy and their kinetic energy increased. So now they're moving around faster. The water molecules in the ice, they're moving around a little bit faster. So temperature measures the kinetic energy of the particles. So since they are moving faster now, the final temperature is now higher than before. That's how you know thermal energy transferred from the hot water to the ice. It's because when thermal energy was added, the particles' kinetic energy increased and the temperature changed, and it went up to a higher number. That is how you know. Alright, so one more time, how can we know that thermal energy has transferred? Well, we know that thermal energy has transferred if the kinetic energy changes. So when I add thermal energy, how can I know that thermal energy from the fire has transferred to the particles? Well, if the particles start to move faster and their kinetic energy changes, that's how I will know that thermal energy has been added. And how will I know if they're moving faster and their kinetic energy has changed? Well, I will have to look at the thermometer. The temperature is increasing. The temperature is changing. So that lets me know that the particles are moving faster because their kinetic energy is increasing. And that's all because thermal energy has transferred from the fire to the particles. All right, so one more time. I know it might be a little confusing, so let me say it again. But we know that thermal energy has transferred if the kinetic energy changes. So if the particles start to move faster or slower, that's how we know that thermal energy was added or removed. And we can measure the change in kinetic energy by measuring the change in the temperature. Remember, you cannot see the actual particles in water. You can't really see it moving, they're too small. But you can know how fast or how slow they're moving by measuring the temperature. So by measuring the change in the temperature, you're measuring the change in the kinetic energy. And if the kinetic energy changed, that means that thermal energy was transferred. Alright, so you've made it to the end of the video. Thank you for watching all the way until the end. So now it's time to do your homework on Schoology. So in order to turn in today's homework, you need to prove to me that you've watched the entire video. So you're going to send me a message on Schoology with the secret word. And once I receive your message, I will give you access to today's homework assignment. So I'm going to say the secret word very soon, but as soon as I say it, you're going to exit the video, go on Schoology, send me a message, and once I get your message, I will give you access to complete today's homework. Alright, so today's secret word is pineapple. One more time, the secret word is pineapple. So I'm going to show you, you're going to exit this video, you're going to go back on Schoology, you're going to press new message, and you're going to type my name, Y-O-U, and you will have to be patient, but wait till my name comes up, Miss You, and then type in secret word and type pineapple and press send. And then once I get your message right over here, then I will give you access to today's homework assignment, which you're going to see on Schoology right over here. All right, good job, students. Thank you for listening and for watching today's lesson. I hope that you complete your homework assignment by tonight or by Thursday night the latest, and I will update your scores on Schoology. All right, have a good rest of your day. Bye.